In this mole ratio lab, we will be combining two reactants, producing a gas, and then capturing the gas in a graduated cylinder so that we can read its volume. I have here the pieces of equipment that we'll be using in the lab. I have a large graduated cylinder, I have a container full of tap water, and I have a stopper with a hose attached, and my Erlenmeyer flask. So I will be filling up the graduated cylinder so that it is completely full all the way to the tip top. Then I'll be inverting the graduated cylinder and submerging it and trying to do that in one swift motion so that I don't have any air bubbles that go inside of the graduated cylinder. So I'll place my hand on top and then quickly go under. Now I do have an air bubble, small air bubble at the top, and if you have a large enough air bubble, then you'll want to read the volume of that air bubble and then subtract that from the volume of the gas that you collect. So now I'm going to keep it submerged and tighten it here into my clamp. And then during the experiment, we'll be able to zoom into the graduated cylinder so that we can clearly read the numbers. So if we can zoom in to the graduated cylinder, then we can see the graduation marks on the graduated cylinder, and each graduation mark is 5 milliliters. All right, so I'm just gonna scoot it over here so that we can see it. There we go. All right, so we'll be able to zoom in, so you'll be able to take an accurate volume reading. And as the bubbles come up, the water is going to be pushed out through the bottom and into the bin. And so then we'll be able to read the volume here at the top. Now, I'll also take the end of my tubing and I will submerge it and put it up into the graduated cylinder. And then I'll tape that down so it doesn't move during the experiment. And that's what will carry the gas into the graduated cylinder. I'll be placing the materials inside of my flask and then placing the stopper onto the flask so that I can capture the gas. So that's our setup. Let's talk about how much material we'll be adding for each of the trials. So there's a calculation table in your lab template, and you can see on the left side that we've chosen different ratios. So the two pink lines, we have more acetic acid than we have baking soda, and the two blue lines, we have more baking soda than we have acetic acid. Everyone will do the middle trial, which is a 1-to-1 ratio where we have equal amounts of moles of each of those. So going through the calculation, you can see on the far left, those are the amounts of baking soda that I'll be using in each trial. And you can see the amount of baking soda is gradually getting larger as we go across the 5 trials. So for trial 1, I'll be starting with 0.14 grams of baking soda. And then you'll notice the amount of acetic acid is the same for all of the trials. So we're keeping the amount of acetic acid the same, and we're varying the amount of baking soda. So the baking soda is our independent variable, and the acetic acid is remaining constant. So 0.005 moles equates to about 6 milliliters of acetic acid. So I'll be using 6 milliliters for each of my trials. Okay, I think we're ready to collect some data for trial 1. So I will start getting my chemicals together. I have my 2 substances for trial 1. The first is 6 milliliters of acetic acid, which I'm going to add to my Erlenmeyer flask. And the other is 0.14 grams of baking soda, which I will add and then quickly cap the flask to capture the gas. Have some bubbles starting to collect. All right, over on the left-hand side of the screen, you can see the zoomed in view of the graduated cylinder. Each of the graduation marks are 5 milliliters. So take a moment right now to read the final volume of the gas collected. Okay, so now we're going to test what's left over in the Erlenmeyer flask to see if we have any of our reactants remaining that are unused in the chemical reaction. And we'll do that by adding bromethymol blue, which is an indicator. It will turn yellow if there's additional acid left at the end of the reaction. It will turn blue if there's additional base or baking soda left over. And if neither is left over, if all of the reactants have been used completely, it will turn green, which is neutral. So we'll just pop the cap off here, and then we'll add some drops of bromethymol blue. And you can see here that this remaining solution is yellow, indicating that there is acid left over, unreacted. And this concludes trial 1. For trial 2, we'll be starting with 0.21 grams of baking soda and continuing with 6 milliliters of vinegar. I've got my setup all ready to go. I have my graduated cylinder inverted and filled with water and submerged. And then I have the tube, which is connected here to my stopper, going up inside of the graduated cylinder so that the bubbles will be collected inside. All right, so I'm going to start with my 0.21 grams. And my 6 milliliters of vinegar. Acetic acid is the active component in vinegar. And so you can make this either with pure acetic acid or you can make it with vinegar. So I have 6 grams here, or 6 milliliters, and I'm going to add that to my Erlenmeyer flask. And then I'm going to add the 0.21 grams, and I'm going to quickly place the stopper on top so that any gas that's evolved is collected inside my tube and doesn't go out into the air. You can see that bubbles are starting to collect inside of my graduated cylinder. Remember to shake the cylinder, shake the Erlenmeyer flask so that all the particles inside the flask have the chance to collide and react. And you can see I'm still continuing to collect some bubbles. And then ultimately, when I don't have any more bubbles being collected, I want to read the volume on the left-hand side of the screen. Recall that each of those graduations are 5 milliliters. Okay. Doesn't look like I have any more bubbles to collect, so we'll take a minute and read the volume. And then we'll add the indicator to the flask to see if we have any reactant, either reactant left over. Now, let's do a quick observation of this. One thing I'm noticing here is that there is not any particulates left over in there. It's just a clear, transparent solution. And so I'll add the indicator now. And we swirl it. That looks like a nice bright yellow. So I'll record that into my data table. And that concludes trial 2. We'll be starting trial 3 with the exact same setup that we had before, but this time we'll be reacting a different amount of baking soda. So I have 0.42 grams of baking soda. And I have 6 milliliters of acetic acid. So I'm going to add the acetic acid to the empty flask. And then I'm going to add the 0.42 grams of baking soda and quickly cap it after I add it. See the bubbles collecting in the graduated cylinder. All right, looks like we're about done. So we'll take a moment now to read the volume on the left-hand side of the screen, remembering that each graduation is 5 milliliters. Okay, now we'll do a test to see if we have any leftover material inside of our flask. As I do my observation, my quick observation, I see that everything has been dissolved and the solution is clear and transparent. So now I'll add the indicator to it. And when I swirl that, I see that that is a very nice green color, nice dark green. And that concludes trial 3. For trial 4, we have the same setup that we've had before. We have our 6 milliliters of acetic acid, which I'll be adding to my flask. And then we have 0.84 grams of baking soda, which I will add, and then quickly cap. You can see bubbles are collecting in our graduated cylinder. Nearing the end of our reaction here. Maybe another bubble or two coming up. All right. take the top off, and then we will examine what's inside the beaker. So when I look inside the beaker, it's a little bit cloudy, so I can see that some baking soda has not dissolved. I'll add my indicator now. And now when I mix that together, I can see that it is a blue color. And that concludes trial 4. For trial 5, we'll be using the same setup as before. I have my 6 milliliters of acetic acid, which I'll be adding to my Erlenmeyer flask. And then for trial 5, we have 1.26 grams of baking soda, which I will add to the flask and then quickly cap to capture the gas. We are collecting some bubbles in our graduated cylinder. And when the bubbling stops, we'll be reading a final volume. I see just a few bubbles left. All right. So we'll take a moment to read the final volume. All right, when I take the top off, I can see that there's quite a bit of undissolved baking soda inside of my flask. So I'm going to add the indicator. And I can see that is a nice blue color. And that concludes trial 5. So now you have data for 5 different trials, trial 1 through trial 5. Not only do you have the volume of gas collected, but you also have the color of the resulting solution at the end of the chemical reaction. With these data points in mind, you can now start to determine which ratio is best for the reaction. Please follow your teacher's directions to know what the next steps are.